Okay, again, I want to welcome you to another presentation. My name is Petu Fasha. Today we'll be looking at chemical equilibrium, and specifically we'll be looking at Reti equilibrium constant expressions in terms of Kc and that of Kp. So, what is equilibrium expression? Equilibrium expression is just a way of writing, both the reactant or relating both the reactant and the products. And we are doing it in line with the law of mass action, wherein when we are writing equilibrium expression, the stoichiometric coefficients will serve as now a power of a particular substance. So if we look at this hypothetical reaction, we have A plus B reflexively give us C plus D, meaning that if A plus B can give us C plus D, C plus D can also give us A plus B. This reaction is a reflexive reaction. But then, as you can see here, we have small a, we have small b, we have small c, and small d. These are referred to as moles, or we call stoichiometric coefficients. Stoichiometric coefficients. So these are stoichiometric coefficients, and they are very necessary in this process. So when you are writing equilibrium constant expressions, you may use our stoichiometric coefficients. They are very important. So there will be a reaction that will be given. You got to observe the reaction as to whether the reaction is balanced. Once the reaction is balanced, then you can write the equilibrium constant expression. But before writing equilibrium constant expressions, we have few things that I want you to know. We have Kc and Kp. But when writing equilibrium constant expression, we omit solids. Solids do not appear in equilibrium constant expression. Similarly, liquid also do not appear in equilibrium constant expression. So whenever you have a reaction that consists of solid, those substances will not appear in equilibrium constant expression, but gases and that of gases appear in equilibrium constant expression, and aqueous also appear in equilibrium constant expression. So let's look at this reaction for instance. So if we look at this is a gas. So this is a gas, this is also gas, and this is gas as well. So if I want to write the equilibrium constant expression in terms of Kc, I know that Kc is equal to the concentration of the product, all over the concentration of the reactant. So this is the formula that we are going to use. So Kc is in terms of molar concentration. So if I write a Kc expression for this reaction, we take the product and then we divide it by the reactant. So here now we have the concentration of C raised to the power small c, and then we have the concentration of D raised to the power small d, all over the concentration of A raised to the power small a, and the concentration of B raised to the power small b. So this is in terms of Kc. So if you are writing in terms of Kp, Kp will be equal to the partial pressure of C raised to the power small c, the partial pressure of D raised to the power small d, and then the partial pressure of A raised to the power small a, and the partial pressure of B raised to the power small b. So this is in terms of Kp. So this is Kc expression, and this is Kp expression. So this Kp is in terms of partial pressures of the gases. And then we say partial pressures are individual pressures that are accepted by gases according to John Dalton's law, or Dalton's law of partial pressure. So this is Kc. So if we are to take a reaction like this, we have methane, C, and then we have 2O2, which is a gas. Give us CO2, which is also a gas, plus 2H2O, and in this case, we say this is a gas. Now in this process, water is now itself has a steam. So how do I write the Kc expression and how do I write the Kp expression? So the Kc expression for this will just be equal to the concentration of CO2 multiplied by the concentration of H2O. Remember, this will serve as a power all over the concentration of CH4 all over the concentration of O2 raised to the power 2. So this becomes the Kc expression. In terms of the Kp now, we will have the partial pressure of CO2 multiplied by the partial pressure of H2O all to the second power all over the partial pressure of CH2 and then the partial pressure of O2 all to the power 2. So So this is B, this will be the equilibrium constant expression for Kc, and this will be the equilibrium constant expression for Kb. So now, when you are writing the equilibrium constant expression, the first thing you should know is that you should check as to whether the reaction is balanced. And then remember that solids do not appear. Let's say for instance you have a reaction with this. If you have X solid plus Y, and then this is your gas, it gives us 3xy, which is your gas. Now in this case, this here is 3. Now, this is X, this is 3, this is Y, this is Y, is 3. So reaction is balanced. But this is solid. But we are saying that solids do not appear in the equilibrium constant expression. Because you have the same concentration already. So here, this is going to go out. And then, to write the equilibrium constant expression, we say Kc is now equal to this equal the concentration of xy raised to the power of 3 all over the concentration of y 3. Here, we have 1, but we don't normally write it 1. So in terms of Kb here, say it's a pressure, that is the partial pressure of xy raised to the power of 3 all over the partial pressure of y raised to the power of 1, which is then seen as the partial pressure of xy raised to the power of 3 all over the partial pressure of y. So this will be in terms of Kc, this will be in terms of Kb. So why if you have in terms of this reaction? Case 3, which is in the solid states, gives us 2C, KCl, which is also solid, plus 3O2, which is a gas. Here we have 2. So why if you are asked for the equilibrium constant expression? But this is a solid, so solid do not appear. And then here, so they also do not appear in equilibrium constant expression. So what can I do? I will make the solids and label this. So like Kc is equal to the concentration of the product. So here now, all for the reactant which is 1, so which is equal to the concentration of O2 all to the power. And then for Kb, equal to the partial pressure of O2 raised to the power of 3. So thank you for watching, and I encourage you to always follow my channel. This is Jacob Chiwek, the second comment numbers I can have it 2, or you can just call it by 2 first shot. Subscribe, and then I will appreciate the comments. This is chemistry, and I want to help my young fellows or students coming up so that they be able to get knowledge or they got control over chemistry. That's my dream, and also make like